Let's study various types of triangle. First I see is an acute angle triangle. As you know, what is an acute angle triangle? All the angles in a triangle are less than 90. If you can see, all the triangles that I'm making right now have their angles A, B, C which are less than 90. So all these angles that are being made right now, okay, many angles that are being made in a minute, all these angles are acute angle. But when it becomes equal to 90, it is a right angle triangle. It is a right angle triangle. So what is the range of acute? 0 to 90. If it becomes more than 90, it is no longer an acute angle triangle. But if it has a range of 0 to 90 degree, all the triangles that you can see it right now, where all the angles are less than 90 degree, is an example of an acute angle triangle. So remember the range of an acute angle triangle. Visually it has proved that the range is from 0 to 90. What happens if the angle becomes greater than 90? Then it becomes an obtuse angle triangle. If you can see this triangle, first of all, it's a right angle triangle because one of the angle is 90. But if I increase this right angle triangle from 90 onwards, it keeps on increasing. All this is an example. All the triangle you can see right now which are forming are example of an obtuse angle triangle. The range is from 90 to 180. So if you go from 90 till 180, all the triangles that are being formed are obtuse angle triangle. That's the range that you can understand visually about the obtuse angle triangle. From 90 it starts, where 90 is a right angle triangle and it keeps on increasing from 90. So if one of the angle is greater than 90, it's an obtuse angle triangle. We proved what we studied. Equilateral triangle, the simplest of all the triangles, all the angles are equal, which is equal to 60, and you can see all the sides 10, 10, 10. Three sides and three angles are equal, that is your equilateral triangle. If I try and play with this, if the angles change, so will be the side. So if I keep on changing the angle, it no longer remains to be an equilateral triangle. So does my sides keep on changing. But when I make it 60, 60, 60, automatically the side becomes 10, 10, 10, which means this is proving that if the three angles are equal to 60, then the three sides will be equal. And that is the property of equilateral triangle that we already know. After that, let's move on to an isosceles triangle. What do we know about the isosceles triangle? The two sides are equal and the two angles corresponding to that two sides which are adjacent to that two sides are equal. So let's see 48.7 and 48.7. Angle B is equal to angle C. Why? Because AB is equals to AC. Both were 13.7, right? Earlier, both were 13.7. So that is isosceles triangle. Now if I just try play with it, AB becomes equal to BC. If I do that in this case, both AB and BC you can see here is 13.7. So angle A becomes equal to angle C, which is nothing but 59.6. So again proved, if two sides are equal, the two angles adjacent to two sides will also be equal. If I further play with this triangle and I try and make AB becomes equal to AC. Now this is the only two sides remaining. If I make AB becomes equal to AC, both are 15.3, yes. So angle B becomes equal to angle C, which is 63.4 degree. And that's how simple it is for me to visually prove that in an isosceles triangle, two sides and the two adjacent angles are always equal. And the last of the triangles which we see here is a triangle which comes between acute and obtuse, right angle triangle. One of the angle here is 90 degree and the side opposite to 90 degree, we know that it's an hypotenuse, that is the highest side. We know it's given here is 13.5. Side opposite to 45.5, the next highest is 9.6, correct? It will be the second highest, and the least 44.5 is 9.5. So we know the property of triangle. We also know we can apply Pythagoras theorem to this. X square is equals to a square plus b square. Check it here. If I do 13.5 square, that will be equal to 9.5 square plus 9.6 square. Okay, now let's just play with this triangle and see if this is actually happening in all the case where I make the angle to be as 90 degrees. So let's see a visual proof of this. Now I changed this right angle triangle. All the angles are changed. Now let me again make this as a right angle triangle. So after changing this, when all the sides were changing, because I was changing the triangle, again I make it 90. Then you have 13.7, 9.8, 9.6. Do this Pythagoras theorem applied here. 13.7 square should be equal to 9.8 square plus 9.6 square, which means we visually prove the property of right angle triangle, that will always come out to be true.